2020 paper. Okay, so question number 1, fx equals x cube minus 10 root x minus 4x over x square where x is greater than 0. Show that the equation fx equals 0 has a root alpha in the interval 1.4, 1.5. Okay, how do we show that there is a root? What do we do? First thing is, you substitute the value f of 1.4 and get the value f of 1.5, right? So get these two answers. So f of 1.4, let's type the equation in the calculator. So you can type x cube minus bracket 10 root x minus 4x divided by x square. Can you see? I'm typing the entire equation in the calculator. By the way, you should know when this negative mark is outside. It actually, if you go to expand it manually, the minus mark comes inside both the terms. Okay. So this is a minus 10 root x, and this would become a plus 4x. Okay. So let's give the values. Calc the first x value we are supposed to give is 1.4. Give the first value 1.4. So what do I get? Minus 0.43567, right? Minus 0.43567. The other one. So calc, let's give the value of x is 1.5. So I get 0.598356. 598356. Can you see? So what do we see here? There is a sign change. So you can see there is a sign change. And is that the only thing you should mention? Is that the only thing you should mention? There is a sign change and the graph and fx is continuous, and fx is continuous, and fx is continuous. Therefore fx has root alpha in the interval 1.4, 1.5. This would be a complete answer. Make sure you show the sign change, 1 mark for that, and another mark for the conclusion. Okay, so you get marks for the conclusion. Make sure you show it. Part B, determine f dash x. How do we determine f dash x? First, I'll need to rearrange my fx. Fx is x cube minus 10 root x minus 4x divided by x square. Shall we separate the terms? X cube. Now be really cautious here. I did tell you that this is supposed to be a bracket here. Okay, so when you are expanding it, even though they do not hide it, you must realize this minus mark will go inside to both of them. So I get here minus 10 root x over x square. Here minus minus is plus 4x over x square. So to differentiate, I must have x in the numerator. So x cube minus, can I have the x power? Root x to the power half divided by x to the power 2. So x to the power half minus 2. Subtract the power, how much is it? X to the power half minus 2 is minus half minus 2 is minus 3 over 2. Right, and then here plus 4x divided by x square, so x to the power 1 minus x to the power minus 2. So 1 minus 2, division powers are subtract. I get x to the power minus 1. Is this okay? Okay, so then this is my fx equation rearranged. Now we are ready to create, or we are ready to make f dash x. So when you differentiate, take the power in front, 3x square, here minus 10 into minus 3 over 2, x to the power minus 3 over 2 minus 1 is minus 5 over 2. So then the next one plus 4, you multiply by minus 1, x to the power minus 1 is minus 2. So I end up getting here 3x square. Can I know how much this is? Plus, how much is this? 15. X to the power minus 5 over 2 minus 4x to the power minus 2. Are you okay with that? Okay, so then moving on to part C. They say using x naught equal 1.4 as a first approximation to alpha, apply the Newton-Raphson procedure once to fx to calculate the second approximation to alpha, giving your answer to 3 decimal places. Okay, can I know the Newton-Raphson process equation? xn plus 1 equals xn minus fxn divided by f dash xn. This is the Newton-Raphson process equation. Okay, so then they have told you the first approximation using x naught as 1.4. So the second approximation is x1. X naught is the first approximation. They are asking you to calculate the second approximation, means you have to calculate x1. Are you with me? How do you calculate x1? So we will replace n with 0 in this equation. What do I get? Then I get here x1 equals x naught minus fx naught over f dash x naught. Are you with me? So shall we substitute the value? X naught is, how much is x naught? 1.4, given to us as 1.4, minus f of 1.4 divided by f dash 1.4. So I think f of 1.4 we already have the answer, isn't it? F of 1.4 we already have the answer. That is minus f of 1.4 is minus 0.43567. So we can input some more values. Okay, or else we can input the whole figure here. Okay, so when x is 1.4 minus 0.43567,32481. Okay, so divide by f dash 1.4. How do I get f dash 1.4? So f dash 1.4, to get that, so I'll press the AC button, okay, and I'll give the f dash x equation. What's the f dash x equation? 3x square plus 15x to the power minus 5 over 2 minus 4x to the power minus 2. Are you with me? Okay, so 3x square plus 15x to the power minus 5 over 2 minus 4x to the power minus 2. This is f dash x. So now I need to replace the f dash x value with the x value with 1.4. Okay, I'm going to replace the x with 1.5 and I get 10.30720. 10.30720. So I get something like this, 93, right? Are you with me? Okay, so type the entire thing in the cal and I have the first approximation. You have to give your answer correct to 3 decimal places. Can I know the answer correct to 3 dp? 1.4 minus 0.4356 732481 divided by 10.3072093. You can like reduce a few decimals, okay, that is perfectly fine. Okay, so I have taken an extra load of decimals here, 1.44. So 1.442 correct to 3 decimal places. Okay, is this clear? Okay, question number 2, they say the quadratic equation 5x square minus 2x plus 3 equals 0 has roots alpha and beta. Without solving the equation, write down the value of alpha plus beta and the value of alpha beta. So you all know alpha plus beta is supposed to be what? Minus b over a. So what are your a, b, c values in this quadratic equation? A is 5, the x square coefficient, b is minus 2, the x coefficient, c is 3. So alpha beta is minus b over a, so it's going to be minus b is minus 2 over a is 5. So alpha plus beta is 2 over 5, agreed? Alpha beta is going to be c over a. These are theories. So c value is 3 over a value is 5. Are you with me? Alpha plus beta 2 over 5, alpha beta is 3 over 5. So part B, they say determine giving each answer as a simplified fraction the value of alpha square plus beta square. So you must know, or actually this is a theory also again given in the textbook. Alpha plus beta square, alpha square plus beta square can be written as alpha plus beta whole thing square minus 2 alpha beta. Are you familiar with this? So if you expand alpha plus beta whole thing square, you get alpha square plus beta square plus 2 alpha beta. With the minus 2 alpha beta, those two parts cancel and you remain with alpha square plus beta square. This is directly a formula that you are allowed to quote and it's given in the textbook as well. So alpha plus beta value is 2 over 5 whole thing square minus 2 times alpha beta is 3 over 5. Can I know the answer for this one? How much is the answer? 2 over 5 square minus 6 over 5, how much? Minus 26 over 25. Is that okay? Okay, then the next one, this is B part, Roman number 1. B Roman number 2, they ask you to find alpha cube plus beta cube. So alpha cube plus beta cube, what's the formula? Again, they have given you the exact equation in the F1 book. So directly this is alpha plus beta whole thing cube minus 3 alpha beta times alpha plus beta. So you must remember this equation. You must remember this equation to use for alpha cube plus beta cube. Okay. So let's use the formula. So this is a standard formula that you are allowed to code directly. Okay. So alpha plus beta is gonna be 2 over 5. Okay. So alpha plus beta is gonna be 2 over 5 to the power 3 minus 3 times alpha beta is 3 over 5 into alpha plus beta is 2 over 5. Can you all simplify? This is 8 over 125. This is 18 over 25. Can I know the answer here? How much is the simplified answer? So I get minus 82 over 125. Is that correct? Okay. Then in part C, they ask you determine a quadratic equation that has roots alpha plus beta square and beta plus alpha square, giving your answer in the form px square plus qx plus r equals 0, where p, q, r are integers. So when they give you to find a quadratic equation that has specific roots, what do? You all know the equation that we generally use is x square minus the sum of roots times x plus the product of roots is equal to 0. This is the main equation that we use in F1. So if you have a pair of roots, it's x square minus sum of root times x plus product of roots is equal to 0. So you have the two roots, get the sum and the product. Okay, so what is the sum of the two roots? So your roots are alpha plus beta square, add it with beta plus alpha square. Are you with me? Let's take the like terms together. So alpha and beta, I will add alpha plus beta. Beta square plus alpha square can be rearranged as alpha square plus beta square. Are you with me? Alpha plus beta answer we found, that is 2 over 5. Alpha square plus beta square answer is also found in B Roman number 1. What was the answer? Minus 26 over 25. Can I know the final answer? How much is the final answer? Minus 16 over 25. Then get the product. Sum of roots, product. Product means where you multiply alpha plus beta square is multiplied by beta plus alpha square, right? So this is the product. Multiply alpha into beta is alpha beta. Alpha into alpha square is alpha cube. Beta square into beta is beta cube. Next one, beta square, alpha square. Or you can say alpha square, beta square. Are you with me? So here I have alpha beta plus alpha cube plus beta cube. So, and this is alpha square, beta square is alpha beta whole thing square. Do you agree with me that it is alpha beta whole thing square? Shall we input the values? So what was our alpha beta value? Remind me again. Alpha beta was 3 over 5. Alpha cube plus beta cube answer we got in part B Roman number 2. What is it? Here minus 82 over 125. Alpha beta whole thing square. Alpha beta is 3 over 5. So 3 over 5 square. Can you all type this in the cal? Get me the answer. How much is it? 38 over 125. So it's a matter of typing in the cal. Now let's input it into the equation x square. So the quadratic equation x square minus sum of roots. What was our sum of roots? Minus 16 over 25x. Can you see? I'm inputting into this equation x square minus sum is minus 16 over 25 times x plus product of roots is 38 over 125 equals 0. So this is our quadratic equation. However, they do ask us to get the quadratic equation in the form px square qx plus r, where p, q, r are integers, no fractional coefficients. How do I get rid of the fractions here? Multiply the entire equation with what? 125 So multiply 125 into x square is 125 x square. Minus into minus is plus. 16 over 25 into 125 is 80x. Plus 38 over 125 into 125 will cancel. So plus 38 equals 0. So this is the quadratic equation with the roots that they mentioned above. Okay, is this clear? Question number 3. F z equal is e to the power 4 plus az cube plus bz square plus cz plus d, where a, b, c and d are integers. The complex number 3 plus I and minus 1 minus 2I are roots of the equation f z equals 0. Write down the other roots. So what are the other roots? You know complex root comes in conjugate pairs. So if 3 plus I is one root, then what is obviously the other root? If 3 plus I is one root, the complex conjugate is 3 minus I. Change the sign of the imaginary part, and the other root is minus 1 minus 2I. So the complex conjugate of minus 1 minus 2I is minus 1 plus 2I. You must change the sign of the imaginary part. So these are the other two roots. Okay, is that clear? The two roots, the other two roots are 3 minus I and minus 1 plus 2I. Part B, show all the roots of the equation f z equals 0 on an Argand diagram. So what are the roots? The first root is 3 plus I, the second root was 3 minus I, the third root is minus 1 minus 2I, and the fourth root is minus 1 plus 2I. This can change, okay, the order can obviously change. So let's quickly draw 3 plus I. So on the real axis it's 3. So 1, 2, 3. Let's mark. Okay, so let's mark the values here. Okay, so it's 3 comma 1, 3 plus I. So this is the 3 comma 1. The next one, 3 minus 1. And then minus 1 minus 2I, minus 1 minus 2I, and then minus 1 plus 2I. Okay, can you see the 4 roots? Did you mark it? So give the arrow and mark the coordinates. This is 3, 1, 3 comma 1. This is 3 comma minus 1. This is minus 1 minus 2. And this is minus 1 comma 2. Are you with me? Okay, can you see all the coordinates are clearly marked? And then give the axis name. This is the real axis and this is the imaginary axis. Make sure you name your axis as well. Okay. And then they say determine the values of A, B, C, D. What are A, B, C, D? A, B, C, D are the values that you, basically the expanded equation. So then let's get the quadratic factors first. Now the first pair of roots were 3 minus I and 3 plus I, right? So by combining those two roots, you can create a quadratic factor, isn't it? Did you find the quadratic factor first? Is that the way you all did this? Okay, so let's get the quadratic factor by doing what? Sum of roots and product of roots. So what's the sum of the two roots here? 3 minus I, 3 plus I. 3 and 3, it gives you 6, right? Minus I plus I cancels. Can I know the product of roots here? 3 minus I into 3 plus I. 9 plus 3I minus 3I minus I square plus 3I minus 3I cancels. 9 minus I square is minus 1, so that is a 10. So then the product, so then the quadratic factor here is x square minus sum of root times x plus product of root. So this is one quadratic factor. Are you with me? The other quadratic factor is found by considering minus 1 plus 2I and minus 1 minus 2I. Are you with me? So when you take the sum of the roots, minus 1 plus 2I, you add with minus 1 minus 2I, what do we get? plus 2y minus 2y gets, that's minus 2. The product minus 1 plus 2y minus 1 minus 2y. So minus 1 into minus 1 is 1. Minus 1 into minus 2y is plus 2y. Plus 2y into minus is minus 2y. Plus 2y into minus is minus 4i square. So plus 2y minus 2y cancels. 1 minus 4 into minus 1. So that is 1 plus 4. The answer is 5. Is that okay? So then the product is found and the sum is found. The quadratic factor is x square minus sum of roots is minus 2x plus product of roots. Okay, are you with me? X square minus and the sum of roots. So sum is minus 2x. So which gives the factor x square plus 2x plus 5. Are you with me? Okay, then how do we get fz? fz is made up of the 4 factors, right? So we got the 2 quadratic factors. So you have to multiply the 2 quadratic factors to get the quadratic equation. So fz equation or fx. Yeah, I have got fx, right? Do they want fz? Yeah, they want us to get in fz, right? Okay, so we should have this in terms of z. Shall we convert this to z? Z square minus 6z plus 1. This quadratic equation is going to be z square plus 2z plus 5. Okay, multiply. So then the fz equation is z square. What was the equation? Remind me. Minus 6z plus 10. The other equation is z square plus 2z plus 5. So when you open this, you will get the quadratic equation. Are you with me? So then I get here z square into z to the power, z square is z to the power 4. So multiply. Z square into 2z is plus 2z cube. Z square into plus 5 is plus 5z square. Minus 6z into z square is minus 6z cube. Minus 6z into plus 2 is minus 12z square. Minus 6z into plus 5 is minus 30z. So the final one. Plus 10 into z square is plus 10z square. Plus 10 into plus 2z is plus 20z. Plus 10 into 5 is plus 50. Z to the power 4. 2z cube. Can you add all the z cube terms? 2z cube and minus 6z cube is minus 4z cube. Add the z square terms. Plus 5z square minus 12z square plus 10z square is how much? How much? Plus 3z square. Is that correct? The next part, add the z terms. Minus 30z plus 20z is minus 10z. Minus 10z and then plus 50. So this is your quadratic equation. The a, b, z values can be seen, right? So what are your a values? Determine the values of a, b, c, d. A is the coefficient of z cube. B is the coefficient of z square. C is the coefficient of c. So then a is minus 4. B is 3. And C is minus 10. Do you see that? Are you with me? Okay, is this clear? Okay, so this is the equation. Okay, shall we also give the values of A, B, C, D just to be safe? Yeah, so what are the A, B, C, D values? A is minus 4, B is 3, C is minus 10 and D is plus 50. Okay, so we determine the values of A, B, C and D. Okay. Question number 4. use the standard results for summation r square and summation r to show that summation of 2r minus 1 square equal 1 over 3n 4n square minus 1. Okay, so what are the standard results? By standard results, what do we know? Summation r square is summation r. We'll start with summation r from r equals 1 to n. The equation is n over 2 n plus 1. Summation of r square from r equal 1 to n is n 1 over 6n 1 over 6n n plus 1 2n plus 1. Am I correct? Are these equations okay? Okay, so we need to use these two equations, and also additionally you might need to know the summation of 1 from 1 to n, that will simply be n. Okay, so these are the three main things you need to use here. So let's open up the summation of 2r minus 1 square from r equals 1 to n. Let's open summation. 2r minus 1 square will be 4r square minus, you know this is a square, so this is twice of 2r and minus 1, which is 4r. Minus 1 square is plus 1. Summation from 1 to n. So this will be 4 times summation r square minus 4 times summation r plus 1. R equals 1 to n. Okay, so 4 times summation r square answer is 1 over 6n n plus 1 2n plus 1. Minus 4 times summation r is n over 2 n plus 1 plus summation of 1 is n. Okay. So what do we get here? We need to get the show that, right? Okay, so let's try to get the show that. So this is 2 over 3n n plus 1 2n plus 1. This is minus 2n times n plus 1 plus n, right? Shall we take a term n out in the show that they have taken a 1 over 3n out? Can you see? They have taken out 1 over 3. Shall we also take a 1 over 3n out? Or 1 over 3 and a n out from all these three terms. So you know when you are taking a 1 over 3 out, you are multiplying by 3, and when you are taking n out, you are dividing by n, because a 1 over 3 means when you are taking a number from the denominator, it means you should multiply. Okay, if you are taking a number from the denominator, you must divide. Are you aware of that? So here 2 over 3 into n, the 1 over 3 and n, so when you multiply by 3 and divide by n, only 2 remains, 2n plus 1, 2n plus 1. Here you divide by n, the n cancels and you multiply by 3, so this becomes 6 n plus 1. Here the n is divided by n, that becomes 1, and you multiply by 3, it becomes 3. Do you agree with me? When you take a 1 over 3n out, it means you multiply by 3 and divide by n. All these terms are multiplied by 3 and divided by n. That's what happens. Okay. So 1 over 3n, let's simplify here 2 times. Open the bracket, 2n square plus n plus 2n plus 1 minus 6n minus 6 plus 3. 1 over 3n, 4n square, 1n plus 2n, 3n times 2 is 6n plus 2 minus 6n minus 3. 4n square, the plus 6n and the minus 6n cancels. 2 minus 3 is minus 1. So this is the show that. Am I correct? Okay, next in part B, they asked you, hence find the exact value of the sum of the squares of the odd numbers between 200 and 500. So you are supposed to get the sum of the squares of odd numbers between 200 and 500. So what odd number squares do they want you to find here exactly? Between 200 and 500. What's the first odd number you have? 201. You are supposed to square it. Sum means to add. And the next odd number? 203, 205. You have to keep taking the sum of the squares until which number? So we have 500, I mean between 200 and 500, so it's 499 whole thing square. So you need to get the sum of these squares by using the help of part A. So I think you can see now you need to decide what R values are we going to use here to calculate this. What R values do you need to use to calculate this? Okay. So let's get here. Summation of 2R. Now you know 2R minus 1 is the odd number formula, right? 2R minus 1, 2R plus 1 is the odd number format. 2R is even, adding 1 or subtracting 1 from 2R, an even number will create an odd. Okay, so 2R minus 1 square is the sum of odd numbers. Now what R value do you think I should use to start 201 here? To get 201 here, my R starting value should be the R value that I use here. If I now 2 times some figure, 2 times some R figure minus 1, I want it to be equal to 201 because it needs to start, okay, it needs to start from 201. So 2 into R equal 201 plus 1 is 202, which gives me R is 101. Can you see? So my starting R value is 101. If I use R as 101 here, I get here 2 into 101 minus 1 is 202 minus 1, which is 201. Can you see? My ending value should be what? I need to end this series from whom? 499. So I need this number to be 499. What's the R value I should use? 2R minus 1 equals 499. So 2R equals 500, which gives me R is 250. Can you see what you need to do here? So to create, okay, so to create this number pattern, to create this number series by using this particular format, you have to use R values between 101 and 250. So if you use R as 101, then you get 201 square. Then the next value 102 will give you 203 square. Next value 103 will give you 205 square. So it goes on until 250, which will give you the 499 square. So this is what you need to find. So this is what is equal to 201 square plus 203 square until 499 square. Do you get me? Okay, so let's get this answer. How do I get this answer? Obviously by using the help of part A. So how do I use part A? Summation of 2R minus 1 square from R equals 101 to 250. Now you do realize that the show that I got here, is it from, I mean you can see this show that is valid only if you start R with 1. Okay, so we are starting with 101. We are starting with a different value. So in this case, we learned a special rule, right? So what is it? Summation of 2R minus 1 square from R equals 1 to 250 minus summation of 2R minus 1 square from R equals 1 to 100. Are you with me? Okay, so then we come to this point, and now how do we get the sum of these values? So R equal 1 to 250. So here we have 1 to n equation. So if it's 1 to n, we can directly use it. So here if it's 1 to 250, now replace the n in this equation with 250. What do we get then? 1 over 3 times 250 into 4 times 250 square minus 1. This should be subtracted with, what is this? The other one is, I'll write it down over here. Is it okay? 1 over 3 into, replace n with 100. 100 times 4 into 100 square minus 1. Can you all type everything in the calculator? 1 over 3 into 250 into 4 times 250 square minus 1 minus 1 over 3 into 100 into 4 times 100 square minus 1. So we get here, okay, 1, 2, 3, 4, 5, 6. So I get here 19,499,950. Is this okay? So this is the sum of the squares. This is the sum of all the squares of odd numbers between 200 and 500. Okay, is this clear? Question number 5. The rectangular hyperbola H has equation xy equals 64. The point P 8p comma 8 over p where p is not equal to 0 lies on the hyperbola. Use calculus to show that the normal to hyperbola at p has this equation. Okay. So how do we get the normal to the hyperbola? So first xy equals 64. Shall we get the equation for y? Y equals 64 divided by x, or in other words y equals 64 times x to the power minus 1. Is that okay? So now to get the equation of the normal, what do we need first? First we need to get the gradient of the tangent. So differentiate dy by dx. What happens when you differentiate? Minus 64x to the power minus 2. Minus 1 comes from, subtract 1 from the power. So dy by dx is the gradient of the tangent. Okay, so get the gradient of the tangent by substituting the x value. What's our x value? So this is 64 over x square, right? Shall I write this as minus 64 over x square? It's easier for us to substitute. So gradient of tangent minus 64 over x value. Now we are interested in finding the normal at point P. So we have to get the gradient at the point P. So at point P, x coordinate is 8p. So 8p square. So what happens when you square 8p? Minus 64 on top. 8p square is 64p square. So you create minus 1 over p square is the gradient of the tangent. Is that clear? So then gradient of the normal will be reciprocal and switch the sign. So plus p square. Now let's get the equation of normal. So equation of normal is y minus y1 equals gradient x minus xy. Equation of normal, any straight line follows this format. So y minus y1 is at the point 8p comma 8 over p. So y coordinate is 8 over p. Gradient is p square. X minus x1 is 8p. So we have to simplify this equation to get the show that. Shall I take the denominator, common denominator with p here? So I get here py minus 8 whole thing divided by p. Do you agree with me? P square times x minus 8p. Or else if you wanted, you could have multiplied this entire equation with a p. That is also okay. So now what I'll do here is I'll take this p as a division to the other side as a multiplication. I end up getting here py minus 8 equal p square into p is p cube times x minus 8p. So then py minus 8 equal, open the bracket, x times p cube minus 8p to the power 4. Do you agree with me? The show that has p cube x and py in one side, right? P cube x and py. So p cube x minus py, yeah. So p cube x minus py, which means I had to move this plus py here and the minus 8p to the power 4 to the other side in order to get the show that. So I get here 8p to the power 4. It came over here. Minus 8 stays here. Over here xp cube is waiting. The plus py moves as minus py. Do you see? So to get the show that they've taken 8 out, right? So we take 8 out. We get p to the power 4 minus 1 equals xp cube minus py. Is this okay? Okay, is this clear? This is the show that part A for 5 marks. Okay, then they say in the next part, the normal to the hyperbola at P meets the hyperbola again at Q. So this normal that you found, this equation, the normal, it meets the hyperbola again at Q. Do you get what's happening? So you have this hyperbola here. Okay, you don't need to draw the diagram. Okay, it's not required. So you found the normal at the point P, right? Okay, so this is point P. And you found this is 8p comma 8 over p. You found the normal. So the, tangent is something that looks like this. Normal is something that is perpendicular to the tangent, isn't it? So this is the normal, this red color line. Can you see? So they say the normal meets the hyperbola again at the point Q. Okay, now this is just a rough sketch. Okay, this you cannot rely on this heavily. Okay, because these points are all unknown. But just to give you an idea, the normal meets the hyperbola again. So they are asking you to get the coordinates of Q. How do I get the coordinates of Q? To find the coordinates of Q, I have to find the place where the two curves intersect, meaning solve the two equations simultaneously. Let's solve it simultaneously. What happens? Let's solve what's our equation? xy equals 64. You have to solve it with p cube x p cube x minus py equals 8 times p to the power 4 minus 1. Shall I replace the y value here? So I'll replace y is 64 over x, right? Do you agree with me? So shall I substitute y as 64 over x? So this is solving simultaneously. Okay, let's input the value p cube x minus p times y is 64 over x equals 8 times p to the power 4 minus 1. Let's simplify. So this x is a denominator. I don't want to see x as a denominator. Shall I multiply the entire equation by an x? So what do I get then? P cube x, when you multiply by x, you get p cube x square. Are you with me? Minus p into 64 over x, if you multiply by x, x cancels and you get 64p. Are you with me? Here 8 times p to the power 4 minus 1 times x. So do you see that I have a what? A quadratic equation in x. Can you see x square term is there, x term is there, and the term without x is there. So I get here p cube x square minus 8 times p to the power 4 minus 1x minus 64p equals 0. Can you see that I get this, that I come to this point? Is this okay? Okay, so now we need to solve this equation, right? So we need to either factorize it, or we need to use we have to either we have to find the values of x in terms of p. Okay, so how do we get the value of x in terms of p? Shall I use the, if you are capable of factorizing directly, then you can go ahead. Actually, we know one answer, isn't it? Now, do you see that this normal meets the curve at the 2 points P and Q, right? Can you see that we already know one solution? What is one solution? One solution is 8P, right? X equals 8P is one solution. Do you agree with me? So, if x equals 8P, one solution of this particular equation, okay, one solution of this particular equation is x equals 8p, which means the factor is x minus 8p. Are you with me? So you have to get the other factor. Okay. So one factor is x minus 8p. So you could try to guess the other factor by looking at what we have here. So you have x here, here you have p cube x square. Can you guess what I should put here? Since there is p cube x square, what should I put here? Because the first term, I should put p cube x, right? So then p cube x into p cube x into x is p cube x square. And look at the last term. That's all we need to look. Because we get one factor here. So the other factor we can check. So you can see minus 8p here, and we have 64p. Okay, so what should I put to get minus 64? Minus 8p into plus 8, right? Minus 8p into plus 8 should give me the minus 64p. Can you see? So you can open this in a side and see whether you are actually getting that answer. Are we getting it? P cube x square. Because the middle terms we did not check, right? But it should come. Obviously it will come, but you can double check to verify. Minus 8p into p cube x is minus 8p to the power 4x. Are you with me? Last term minus 8p into plus 8 is minus 64p. Are you with me? So I get here p cube x square. You don't need to do this working. This is just us double checking our work. In the show that they've taken minus 8 and x out. So we'll take minus 8x out. This becomes minus 1. This becomes plus p to the power 4. Can you see? Can you see I'm getting this perfectly? I get that perfectly. Can you see? So then these two factors are correct. So x minus 8p is 0, or p cube x plus 8 is 0, which gives me x is equal to 8 minus 8 over p cube. So they are asking us to get the coordinates of q. Now you know x equal 8p is the coordinate of p. I need to get the coordinate of q. So coordinates of q. So then, sorry, I need to get the y coordinate first, right? How do I get the y coordinate? So when x equals minus 8 over p cube, what is the y value? Y equals 64 over x, right? You can use any one of the two equations. I will use the linear one. Y equals 64 over x. Replace the x value. 64 divided by x is minus 8 divided by p cube. Are you with me? So y equals plus divided by minus is minus. 64 divided by 8 is 8. The p cube, the denominators, denominator here, this p cube comes up. Do you agree with me? The simplification, this p cube should come up over here. So coordinates of q are, x coordinate was minus 8 over p cube, y coordinate is minus 8 p cube. Okay, is this clear? Okay, question number 6, they say describe fully the single transformation represented by the matrix A. Okay, so always when you are describing a transformation, what do you measure it against? Always your starting matrix is what? The identity matrix. Always your starting matrix is the identity matrix. Okay, so you measure everything with respect to 1, 0, 0, 1. Okay, 1, 0 is the x-axis, it's on x-axis, 1, 0, this is 0, 1. Are you with me? So when you draw the line, I draw it like this, right? So this is 1, 0. And this is the 0, 1. Are you with me? Then they say here A is equal to 1, 0, 0, 3. So when you draw it, you don't even need to draw it now when you look at this, because it's you can just look at this and see what has happened. 1, 0 has not changed at all, right? 1, 0 has not changed at all. Okay, 0, 3. So when you see 0, 3, what has happened? X value is 0, y coordinate 3. So what has happened? Can you see that there is a stretch parallel to the y-axis? By how much of a scale factor? By a scale factor 3. So then we say this is a stretch scale factor 3 parallel to which axis? Parallel to which axis? Parallel to the y-axis. Can you see? Because you can see the x-coordinate, the x-axis is not stretching at all. X-axis is as it is in the original matrix. The y-axis is being stretched. Okay. So then always the single transformations are measured with respect to 1, 0, 0, 1. Okay. Then they say the matrix B represents the rotation of 45 degree clockwise about the origin. Write down the matrix B giving each element of the matrix in exact form. Okay. Okay. So then in part B, okay, so when you represent a rotation of 45 degree clockwise about the origin, and when you give each, okay, you have to give each element in exact form. So it's just 1 mark, right? So for 1 mark, you must realize. So in your textbook as well as in your formula booklet, right? So on the FP1 page, you will see matrix transformation, and they have given you the anticlockwise rotation through theta. They have given you the equation, but that is only valid for anticlockwise rotation. So if you rotate anticlockwise rotation about through theta about the origin, the matrix is cos theta sin theta minus sin theta cos theta. Are you with me? This is only valid, however, if you are doing a theta degree anticlockwise rotation. Okay, for theta degree anticlockwise rotation. Theta radian or theta degree anticlockwise rotation. Okay, so then the problem that we have here is we are doing a rotation of 45 clockwise. So a 45 degree clockwise rotation is, in other words, the thing is to use this for 1 mark, I need to have it in anticlockwise. So what can we do? 45 degree clockwise, in other words, can also be written as 45 degree clockwise can also 360 minus 45 degree anticlockwise. Same thing, right? You end up at the same place. 360 minus 45 is 315 degrees anticlockwise. 45 degree clockwise or traveling 315 degree anticlockwise is the same. So now let's input that into this equation. The matrix cos 315 sin 315 minus sin 315 cos 315. Can I know the answer? Root 2 over 2. The other one? Check the signs. This is minus root 2. Sine 315 is minus root 2 over 2, right? Because it's in the third quadrant. Yeah, sorry, fourth quadrant. And then minus sine 315 is, that is plus 2 root 2. Plus root 2 over 2. Cos 315 is plus root 2 over 2. So this is the matrix just for 1 mark. Actually, you don't need to write any of these things. Just writing this is perfectly okay. Okay, it's just 1 mark. They only want to see this. So this is our extra working and the thought process. I have written the thought process here. Okay. They say the transformation represented by matrix A followed by the transformation represented by matrix B is represented by matrix C. Determine C. So do you remember this followed by rule? So when a matrix is followed by the other one, how do we normally write it? So matrix A followed by matrix B. Do we write AB or do we write BA? Matrix A followed by B is, so C is equal to matrix A followed by person is written into the left side. Do you remember? So matrix A followed by B. B is written to the left of it. So BA. Okay, so they have told you to determine C. Okay, so matrix B we found, right? Write down matrix B. This is what we got in part B. Isn't it? Okay, so then let's simplify. Matrix B was root 2 over 2 minus root 2 over 2, root 2 over 2, root 2 over 2. And matrix A is, what is matrix A? 1, 0, 0, 3. Shall we multiply? So it's better if you multiply it manually, because if you go to give this in the cal, it will give you decimals. Okay, so shall we multiply it manually? So you know here it's 2 by 2 matrix with 2 by 2 matrix. You will end up getting another 2 by 2 matrix. Are you with me? You are ending up getting another 2 by 2 matrix, which means there are 2 rows and there are 4 elements. Okay, so remember we take the rows from the first column. We take rows from the first matrix and we take the columns from the second matrix. Are you familiar with that? Rows are taken from the first matrix, columns are taken from the second matrix. So here the first element is a combination of row 1, column 1. Okay, first element is row 1, column 1, second element is row 1, column 2, third element row 2, column 1, fourth element row 2, column 2. Shall we multiply? Okay, so you don't need to write all these things. I'm just doing some extra stuff here. Row 1 and column 1, can you multiply? Row 1 is root 2 over 2, root 2 over 2 with 1, 0. So root 2 over 2 into 1 is root 2 over 2 plus root 2 over 2 into 0 is 0. Can you see? I'm directly doing it. The second element is row 1 with column 2. So row 1 and column 2. So row 1 root 2 over 2 times 0. Can you see? Root 2 over 2 times 0, that is 0, plus this root 2 over 2 times 3, which is 3 root 2 over 2. Are you figuring out what's going on here? This guy with this 0 and then this guy with this 3. That's how you multiply, isn't it? Okay, then the next element is second row, column 1. Second row and the first column. So second row, root 2 over 2. Root 2 over 2 will multiply with 1. Minus root 2 over 2 times 1 and plus root 2 over 2 times 0. How much is it? Minus root 2 over 2 into 1 is minus root 2 over 2 and this into 0 is 0. So answer is minus root 2 over 2. And then the next one, minus root 2 over 2 into 0. The row 2, column 2. Okay, row 2, column 2 and root 2 over 2 into 3. What's the answer? Minus root 2 over 2 into 0 is 0. Root 2 over 2 into 3 is 3 root 2 over 2. Okay, so this is the answer. Is this okay? Okay, so if you want, you could maybe, okay, how have they asked, have they given us any format? No, they determine C, so we could keep like this, or else Root 2 is a common factor to everyone. You could take a root 2 over 2. Actually, root 2 over 2 is common to everyone. You could take a root 2 over 2 and write 1 minus 1, 3, 3. If you know what I'm talking about, like you could leave your answer in this form or take a root 2 over 2 out and say 1 minus 1, 3, 3. Can you see? A simpler matrix. Okay, so you can leave your answer in this form. This is perfectly fine. Okay, any equivalent answer is correct. Okay, any equivalent answer, this as a final answer is perfectly okay. Now the next part they say, the trapezium T has vertices at the points minus 2, 0, minus 2k, 5, 8 and 5, 0 where k is a positive constant. Trapezium T is transformed onto trapezium T dash by the matrix 5, minus 2, 1, 3. Given that the area of trapezium T dash is 510 square units, calculate the value of k. Okay, so how do we get the value of k? Normally when you have this area question, how do we work with the area question? What is the equation for the area? What is the equation for the area? Area of object, area of T into determinant of the transformation matrix equals to area of image. This is the main equation that you have to use, isn't it? So, okay, so area of image, do we know? Yes, area of the trapezium T dash. The image is given as 510 square units. Okay, and then determinant M can't we find? The modulus of the determinant. Modulus means the positive value of the determinant must be found. We can find it. And what about the area of the trapezium T? So, you will have to do a quick sketch of it. Can we do a quick sketch of it? Because you have to find the area. So what are our coordinates? Minus 2, 0, minus 2, k, where k is a positive constant, which means minus 2, k should be up over here. Are you with me? And the next point is 5, 8. So 5, 8, I do not know whether, okay, 5, 8. So 8, I'm just randomly placing it here. Five, 8 and 5, 0, which means they are directly underneath each other, right? Can you see? So this is your trapezium. Can you see the trapezium? Okay, I just 8, the value 8, you could mark it underneath k also, because we do not know whether 8 is bigger than k or lower than 8. Okay, so you can randomly mark. All I need to see is the figure. And now get the area of the trapezium. What's the area of a trapezium? Half the sum of the parallel lines into height. So what are the parallel lines here? Can you see these are the two parallel lines? And what are the lengths of the parallel lines? One is k, the other one is 8. Into what's the perpendicular height? What is the perpendicular height? This distance, right? From 5 to minus 2, how much of a distance? 5 units and 2 units, altogether 7 units. Can you see? It's not 5 minus 2, it's not 3. I need the length here. How much of a distance do I have? The length is 7. Are you with me? Are you with me? So area of T. Now, shall we substitute this value into this equation? And also we have to get determinant of M. Can you find determinant of M also? So can you all get me the determinant? 5 minus 2, 1, 3. Multiply along the main diagonal. What is it? 5 into 3. Subtract with minus 2 into 1. Do you know what I'm doing here? I'm taking the determinant of this matrix here. 5 times 3. First main diagonal. Subtracting with minus 2 times 1. How much is the answer? 15 plus 2. Answer is 17. Can you see? Answer is 17. So then we are ready now. Shall we substitute everything into our equation? Area of T into modulus of the determinant of M equals area of T dash. Area of T is half times k plus 8 into 7. Determinant of M is 17 equal area of T dash is 510 square units. Are you with me? I will make k plus 8 the subject. That gives me 510 times 2 divided by 7 times 17. The 2 goes up, 7 and 17 comes down as a division. How much is k plus 8? How much is k plus 8? Type in the calculator. 510 times 2 over 7 times 17. How much? 60 over 7. Then final answer to get k, 60 over 7. Minus 8. How much is 60 over 7 minus 8? 60 over 7 minus 8. 4 over 7. So this is the value of your k. 5 marks. Can you see how it's done? Question number 7. The parabola has equation y square equals 4ax where a is a positive constant. The line L with equation 3x minus 4y plus 48 equals 0 is a tangent to curve at point P. Show that a equals 9. Okay, how do we find this? How do we show that a equals 9? What's the first thing that you do here? So the parabola equation is given and the line L equation is given. You have to show that the line is a tangent at the point P. Okay, so what do we do? Y square equals 4ax and the other equation is 3x minus 4y plus 48 equals 0. Okay, so what do we do with these two equations? To show this particular line is a tangent, first what do we do? What's the first thing to do? Okay, so we need to show that there is only one, they say that it's a tangent, so there will only be one cutting point. Solve the equation simultaneously. So let's solve the equation simultaneously. I already have y square equals 4ax here. Okay, so making x the subject is easy for us here, isn't it? Rather than making y, because then you get a square root. So I get here x is y square over 4a. Shall we replace it in the second equation? So 3x minus 4, sorry, I'll replace it here. 3x is, the x is the y square over 4a. 3x, I replace by y square over 4a minus 4y plus 48 equals 0. Okay, so to work with this equation, I can't have the 4a down as a denominator. I will multiply the entire equation with 4a. So what do we get here? 3y square minus 4 times 4 is 16ay. Can you all multiply 48 times 4? 192. 192a equals 0. So 3y square 16ay plus 192a equals 0. So you have a quadratic equation in y. Now if you are, now they tell you very clearly the line L is a tangent. They are not asking you to show that it's a tangent, right? They are saying to you as a fact it is a tangent and thereby show that a is 9. So if your line is a tangent to the curve, now even though when you have a quadratic equation you expect to see two answers. But if it's a tangent, how many times will it intersect with the curve? A tangent will only intersect once, which means this quadratic equation is only going to have one solution. So one solution means your discriminant will be 0. So to be a tangent, b square minus 4ac must be equal to 0. Let's input the value. B is how much? Minus 16a, because the coefficient of y is b. B square minus 4 into a is the y square coefficient, which is 3, into c is the coefficient without y, which is 192a. Can you see the ABC coefficients? So a is the 3, b is the minus 16y, c is the 192 plus 192. This is ABC. Okay, so solve this equation and equal to 0 and get the a value. How much is 16 square? 256a square minus 4 into 3 into 192 is 2304a. So I'll take a out. 256a minus 2304. You could simplify, you could take more out, huh? Like there are more in common that we could take out, so I did not bother to here. So I get A is 0 or 256A minus 2304 is 0. So A is 2304 divided by 256, which is A equals 9. So they do tell us A is a positive constant, right? So A is a positive constant. So this is not a solution. A is a positive constant, so the only answer for A is A equals 9. This is the only solution. Is this clear? Okay, part B, hence determine the coordinates of P. Okay, how can I get the coordinates of P? Coordinates of P are where the tangent and the line intersects. So I think we got a kind of like a quadratic equation where by equating the tangent and by equating the line and the curve, right? So this the intermediate equation we got is this. Can you see this intermediate equation? This one. So this one will give you the solution. Shall we use that one? So in part B, 3y square minus 16ay plus 192a equals 0. Replace first the a value. 16 times a is 9 plus 192 times a is 9. 3y square, 16 times 9 is 144y. 192 times 9, 1728. Okay, so does this factorize? So we'll factorize. Question, so degree 2, 3y square minus 144y plus 1728. So I get x equals 24. Now, though you get x here, are you going to write the answer as x minus 24? No, can you see your quadratic equation is with what? Is with respect to y. So be very cautious. Okay, be very cautious. This answer, though they give for x, do not write x minus 24. Okay, so the factor here is y minus 24 is one factor. The other one is y equals, sorry. So we only get one answer, right? So it's actually a, sorry, I think we can simplify this here with 3. Shall we first divide by 3? Simplify this equation with 3 because, yeah, divide with 3 first because we should get the simplest answer and then go for the calc. Y square minus 48y plus 576. So we should get the same answers. Okay, even though the coefficients will change, it's a multiple, so answer should not change. 3 minus 144, 576 gives me the same answer. Sorry. Right. Sorry, this is y square, 1y square, right? 1 minus 48, I have not given it correctly, minus 48, this one is 576. Now I gave it correctly, right? Minus 48, yeah, I gave it correctly. So I get the same answer. Can you see? X equal 25. I'm not getting x1, x2. What does that tell you? It's a repeating rule because if the same bracket comes twice, that's why we get a repeating rule. So only one answer. There's no x1, x2 because normally in the calculator you get x1, x2, which means the same factor is repeated. So this is y minus 24. The other one also should be y minus 24. So only one answer. Why? Because it's a tangent. So y equal 24. Now get the coordinate means also you have to get the x coordinate. What is the x coordinate? Substitute to the equation. So y square equal 4ax. Because if the x is not a quadratic term here, we can go with y square equal 4ax. Okay. So if this x had a power 2, then I would prefer to definitely go with the linear equation. Okay, or else shall we go with the linear, because my advice to you is when you solve simultaneous, always substitute to the linear equation and get the answer. So 3x minus 4 times y is 24 plus 48. Can I know the answer for x? Minus 4 times 24 goes as plus 4 times 24 minus 48. How much is 4 times 24 minus 48? How much is it? 48 divided by 3. Divide by 3, x is 16. So coordinates of P coordinates are 16, 24. Are you with me? Is this clear? And then in the next one they say, given that the point S is the focus of C and that the line L crosses the directrix of C at point A, determine the exact area of triangle PSA. Okay, so to understand it, it's better that you actually what? Draw a diagram, draw a quick sketch so you realize what is going on. Okay, so let's draw a quick sketch. So we have a parabola. Okay, so we have a parabola, and you know in a parabola this is how the equation goes, right? This is the parabola equation. Focus is at a comma 0. Are you aware? Focus is at a comma 0. Directrix is at x equal minus a. Are you with me? Directrix is at x equal minus a, or x plus a equals 0. Isn't it? Okay, so we found the a value is 9, right? Okay, given that the point S is the focus. Okay, so this point S is the focus of C, and the line L crosses the directrix. Now we found that line L is actually what? Line L is a tangent. Line L is a tangent to which point? The line L is the tangent to the point P. What's point P? 16, 24, right? So mark a point roughly 16, 24 somewhere over here. 16, 24. So draw the tangent at 16, 24. So we get something like this, right? The point S is the focus. This is the point P. Okay. The line L crosses the directrix of C at the point A. So this is the directrix. You cross the directrix at the point A. Can you see? The directrix you cut at point A. Determine the exact area of triangle PSA. So can you see the PSA, the 3 points? So you need to find the area of the triangle PSA. Are you with me? Okay, so this is your task. Your task is to get the area of triangle PSA. Okay, how do we do this? What is the procedure? Okay, so the first thing we do is first we'll get the A coordinate. Actually, this A value is known. We know A is 9, right? Shall I replace A with 9 first? So this is 9, 0, x is minus 9. Can I know the A coordinate? How do I get the A coordinate? Substitute x equals 9 to the equation of the line. We have the line equation. So replace. So when x is minus 9, you get here y equals, 3x. The equation is 3x. So 3 into minus 9 minus 4y plus 48 equals 0. 3 into minus 9 is minus 27 minus 4y plus 48. So minus 4y comes here as plus 4y. Minus 27 plus 48. How much is y? Minus 27 plus 48 is 21. So we get here, how much was it? Minus 27 plus 48 was 21. So y equals 21 divided by 4, right? Which is 5.25. So this is 5.25. So the A coordinate is minus 9, 5.25. Okay. Okay, so now how are we going to get the area of the triangle PSA? So what is the strategy you are going to use here? To get this area, now you might think, okay, to get the area of triangle PSA, can't we use half into base into height? But then your base, if you use PA as the base and try to find the perpendicular height, that's going to be really tough, right? To get this perpendicular height here, we do not know the height and we do not know where the perpendicular will land. So you can get the PA distance, but after that, how do we get the perpendicular height? Okay, so there are many strategies here. So involving where you get the lengths, okay, where you can use the cosine rule, and if you know the lengths you can get the angle, but those are like very difficult and very long techniques. So we can go in a more shorter method. So what is a shorter method? Look, so you just need to look a little bit. So I need to get the area of triangle PSA, right? That's my end target. To get this end target, can you see now? I'll consider something like this. A trapezium. Can you see a trapezium here? So from this trapezium, can you see that I can subtract these two right angle triangles and actually get the area of triangle PSA? This is a lot easier for us to work with, right? We know all the coordinates and we can easily find the area of these two right angle triangles. Isn't it? Okay, so then one common misconception is some of you might think that this is a right angle here and might go for a right angle triangle taking PS, PAS as the base and height. So that also we do not have any confirmation. So unless you get the gradients and see whether it becomes -1, you can't just assume there's a right angle here. Okay, so this is based on the questions I'm hearing right now. So the best way to go with here, because we do not know any of the angles. Okay, because we do not know any of the angles, to use even half AB sin C, we do not know any angle. So to find, you'll have to find the angle. So rather than going in that direction, I think the easiest thing here is to take a trapezium and subtract these two right angle triangles, because we know the base and heights of these two right angles very clearly. Okay, so let's get the area of the trapezium. What's the area of the trapezium? So area of trapezium is half A plus B. What are A and B? A and B are these two heights. So it's 5.25 and 24, right? The y coordinates 5.25, 24 into how much is the height? What's the perpendicular distance between the two parallel lines? What's the perpendicular distance here? So this is the x coordinate here is 16. The y coordinate here is -9. So end of the day, how much of a distance do I have from -9 to 16? Add the 16 and add the 9. The length is 25 units. So 25. Half into base into height is 25. What is the area of the trapezium? Half into 5.25 plus 24 into 25. How much is it? Fraction answer? 2925 over 8. Is this correct? Now let's get the area of the right angle triangles. So area of triangles, half into base into height. Let's add them up. What is the base of this first triangle? How much is this base? 18. And what is the height of this triangle? 5.25. Half into 18 into 5.25 plus at the area of the other triangle, half into base of this other triangle is from 9 to 16. How much is the base? 9 to 16? 16 minus 9 is 7 and height is 24. Half into 7 into 24. Can I know how much is the answer for the area of the two triangles? Yeah, how much? 525 over 4. So then now we can go for area of, what is the name? PSA. Area of PSA. So area of PSA is 2000. The area of the trapezium, subtracting with the area of the two triangles. How much is it? 1875 over 8. Do they want exact answer or 3SF? What is it? Determine the exact area. So this is the exact area. You can leave it like this. Or 234.375. The exact area is what they want. 1875 over 8 square units. Okay, is this clear? Question number 8. Prove by induction that for n element of positive integers, 2r square minus 1 over r square r plus 1 square. The summation from 1 to n is equal to this n square over n plus 1 square. So you have to prove it by induction that the summation from 1 to n is equal to this. Okay, so what's the starting step? First, we have to check when n equals 1, right? When n equals 1, let's check whether the summation formula is true. So when summation from r equals 1 to 1 for 2r square minus 1 over r square r plus 1 square. Replace r with 1, what do we get? 2 into 1 square minus 1. 1 square times 1 plus 1 is 2 square. Can you all tell me the answer here? So 2 into 1 square is 2 minus 1. 1 square is 1 into 2 square is 4. So I get here 1 over 4. The summation of the first term is basically r equals 1 to 1 means we just take the very first term, right? So the very first term is simply 1 over 4. Okay, then we have to check whether this is aligning with the other side. Okay, so check whether it's aligning with the other side. So in the other side we have n square over n plus 1 square. So when n is 1, what do we get? 1 square over 1 plus 1 square, which is 1 square is 1, 1 plus 1 is 2, 2 square is 4. So the left hand side and right hand side are equal, right? So the summation formula is true for what? Summation formula is true. So you must have a base idea about the lesson to know what I am talking about. Huh? Summation formula is true for n equals 1. Then next in induction, proof by induction, what's the next step? In proof by induction, the next step is where we assume, right? Assume, what is it? Summation formula is true for what? For n equals k. So we'll take the summation formula for n equals k. So summation of r from 1 to, instead of n, now we go to n equals k. Can you see? Instead of going to 1, we go from 1 to k because n is k. So that means you take the sum of the first k terms. 2r square minus 1 over r square times r plus 1 square is equal to what? So we assume that the summation of the first k terms is given by what? What do we use for k? Instead of n we use k. So k square over k plus 1 square. Are you with me? Okay, then in the next one, what's the next step in proof by induction? So I have the summation of the first k terms. Now we go for the summation of k plus 1 term and we do it manually. Okay, so now in the next step we take the for k plus 1 terms. Okay, so for k plus 1 terms we are going to take the summation in the next step and we have to get the k plus 1 term summation in a manual way. 2r square minus 1 over r square times r plus 1 square. So what happens here? When r is 1, right? Now shall I directly go for the answer? Do you realize here the summation of r of this person from r equal 1 to k plus 1 can be written as a summation of 2r square minus 1 over r square r plus 1 square from where to where? From 1 to k, and then what else is remaining? 1 to k means you add the first k terms and there's another k plus 1th term. So replace the r with k plus 1, right? Because that's the k plus 1 term. So 2 times k plus 1 square minus 1 over k plus 1 square. K plus 1 is k plus 2 square. Can you see what I did here? This summation means first you put r is 1 and get the answer, plus then you put r is 2. You get the answer for this, plus r is 3. You get the answer. Keep on doing until r is k and you get the answer. Plus then r is k plus 1, which is this answer. Then the summation from 1 to k terms is this. I did not go to write it manually. That answer is what we have assumed in the previous step. Can you see we have assumed the summation of this from 1 to k is what? Can you see that this part has been assumed in the top part? That we have assumed it. Summation of r from summation of this particular equation from 1 to k is this. Can you see we have already assumed it? So it is k square over k plus 1 square. Here shall we simplify? 2 times k square plus 2k plus 1, I open the bracket, minus 1 over, are we going to expand the denominator? Is it wise to expand the denominator? No. Numerator, yes, because we have to simplify, but denominator do not expand. Okay, so then let's simplify. K plus 1 square, k plus 2 square. So here I get k square times k plus 2 square, because here I am missing the k plus 2 square component. I multiply with k plus 2. Here I have both of them, right? So nothing to add here. 2 times k square plus 2k plus 1 minus 1. Are you with me? By the way, what's our show that? What do we need to end up getting? Do we know what's the ending idea? What is the ending idea? Now I'm trying to get the summation of how many terms? I'm trying to get the summation of k plus 1 terms. So if you replace n with k plus 1, what's supposed to be our end goal? Replace n with k plus 1. So we are supposed to get k plus 1 square over k plus 1 plus 1 means k plus 2 square. So this is what I need to get. When I open this summation manually to k plus 1 terms, I have to replace then with k plus 1, and I have to get this answer by opening the summation formula manually. So right now I have opened the summation formula manually. Now I need to show that this particular summation formula will give me an answer that looks like this. Okay, so shall we simplify? Okay, let's open the brackets now. So k square, here k plus 2 square is k square plus 2 k and 2 when you double it, that's 4k plus 1, sorry, plus 4. Do you agree? This is 2k square plus 4k plus 1 minus 1, whole thing divided by k plus 1 square, k plus 2 square. Open the bracket. K to the power 4 plus 4k cube plus 4k square plus 2k square plus 4k plus 1 minus 1 will cancel, right? Sorry, this is a plus 2, isn't it? 2k square plus 4k, 1 into 2 is a 2 here. This should be a 2. So 2 minus 1 should give me plus 1. Okay, so there was an error I made here. 2 into 1 should be 2 here. K plus 1 square, k plus 2 square. So what do I get? K to the power 4 plus 4k cube plus 4k square plus 2k square. I can add it, right? Which is 6k square plus 4k plus 1 over k plus 1 square, k plus 2 square. Are you with me? Are you with me? Okay, now you know what your final answer is supposed to look like, right? You know your final answer is supposed to look as k plus 1 square divided by k plus 2 square. So keeping this in your mind, okay, you need to keep this in your mind always. This is what the final answer is supposed to look like. Okay, so how are we going to get this final answer here? How do you think now? I have to factorize this top part, right? I have to factorize. How do I factorize this top part? We can't take any k or k square out. There's a plus 1 here. Okay? You cannot factorize out here any common term, any common letter. There's a plus 1 here. So you need to think how to get this. So be strategic. So what do you think is happening here? So do you see here definitely to get there is a k plus 1 square in the denominator, right? Okay, and then at the end of the day you have to have a k plus 1 square remaining in the numerator also. Isn't it? So can you guess what this expansion is? This is actually a full expansion of what? Can you guess what it is? This is the full expansion of what? K plus 1 to the power 4. Very good. This is the expansion of k plus 1 to the power 4. So you need to kind of keep the show that in your mind. Because we need to get this, right? Our final answer should be this. So this you can expand and see, you will definitely get this. Okay, so I'm not going to go into that point. Okay, so try to use a little bit of your common sense and try to see, okay, I want to get this answer, what should I do? So then we can simplify, this becomes k plus 1 square cancel, so I get k plus 1 square over k plus 2 square, but bear in mind that if you write this for an incorrect expression here, will you get the marks? No. Okay, so in an event, if you have any sign, if there is any sign error, or if there is any k value or any figure, if there is any figure that does not add up, or if it doesn't look like this, okay, you will not get the mark even though you write it, because we just kind of like looked at it and had a guess here. But so if the expression above does not tally with this, you will not be awarded marks. Okay, so the simplification must be done perfectly. The addings, the subtracting, and the simplifying, the multiplications must be perfectly there. Okay, are you okay with that? So now make sure you give the conclusion, because you get 1 mark for the conclusion. So you can say if the summation or if the result or if the summation formula is true, the summation formula is true for n equals k, then it is true, right? We showed it is true for what? Then it is true for n equals k plus 1, right? So we assume the summation formula is true for n equal k, and it is true for n equal k plus 1. Then the summation formula, or they say the word the result, we can use the word result. The summation formula has been shown to be true for n equal 1, then the result is true for what? The result is true for all n values. Then the result is true for all n. Okay, so make sure you give the conclusion properly, because if the conclusion is not solidly given, you will not get the final mark. Okay, make sure the final part is given clearly. Okay, moving on to Roman number 2. Prove by induction that for n positive integers of n, Fn equals 12 to the power n plus 2 times 5 to the power n minus 1 is divisible by 7. Okay, so how do we prove it's divisible by 7? How do we start this proof? First we start for n equals 1. So we have to check whether for n equals 1, whether this is divisible by 7. So F1 gives me 12 to the power 1 plus 2 into 5 to the power 1 minus 1 is 0. How much is it? 12 plus 2, 5 to the power 0 is 1. So 12 plus 2 into 1 is 2. 12 plus 2 is 14. So you can see 14 is what? 14 is divisible by 7. Do you agree? 14 is divisible by 7. Then the next step is, we assume, right? Assume for n equals k, Fk is divisible by 7. Are you with me? So what is Fk? We have Fn. Fk is equal to 12 to the power k plus 2 times 5 to the power k minus 1. Are you with me? Okay, so then let's get the next step. So what's the next step? You have to show that what? What is your task now? Your task is to show that Fk plus 1 is divisible by 7. Are you with me? Your task is to show that f of k plus 1, the next term, the next k plus 1th term is where you have to do the manual work, right? You know, in the proof by induction sums. So the k plus 1th term, you have to show that it is having a factor of 7. Thereby it is divisible by 7. So your task now is to get something for Fk plus 1 such that what? Such that it has a factor of 7. Can I know what is Fk plus 1? Fk plus 1 will be 12 to the power k plus 1 plus 2 into 5 to the power k plus 1 minus 1 is 5 to the power k. K plus 1 minus 1, the minus 1 plus 1 cancels. Can you see? So your task is to show that this particular value here that we can derive, we can take a 7 out of it. So it's divisible by 7. But you can see at first glance, can we take any 7 out of this? No, right? It doesn't look like it has a 7. So let me just simplify this here. So this is 12 to the power, k plus 1 plus 2 to the power 5 times k plus 1 minus 1. Shall I write it like this? Okay, so the reason I'm writing it like this is we prefer to keep our fk plus 1 in the same powers of fk. Okay, so look at this. I'm going to simplify fk plus 1 slightly. So 12 to the power k plus 1, I'm going to break it as 12 to the power k into 12 to the power 1. Is that correct? And the next one also, you can see fk has a 5 to the power k minus 1. So here also I prefer to break it as 5 to the power k minus 1 separately. And the plus 1. Can you see I just did a slight rearrangement here. I brought the minus 1 in front and the plus 1 to the other side. I'm rearranging so I can break it up into this same set of powers. The powers. The 12 I want to have it with the power k and 5 I want to have it with the power k minus 1. So I get here 12 to the power k into 12 plus 2 into, how will I break it? 5 to the power k minus 1 into 5 to the power 1. So this is 12 times 12 to the power k. Here of course 5 times 2 I can make it a 10, right? 10 into 5 to the power k minus 1. Do you agree with me? Do you agree with me? Okay, so then fk plus, now the next step is, now am I still creating any kind of a 7 here? My task is to show that fk plus 1 has a factor of 7 that I can take out. But I can't take out any 7 here. So then when you come to this point where you can't simplify anymore, we will do an extra step in division. In your textbook they teach you this. So we go for what? Fk plus 1 minus fk. So we subtract from the k plus 1 term, we subtract the kth term. Okay, so to help us to generate the 7. Okay, so this is a technique you learn in your textbook. Okay, it's taught you in the example in the textbook. You will see that this is the technique that they follow. So 12 into 12 to the power k plus 10 into 5 to the power k minus 1. So this subtract by fk is 12 to the power k plus 2 into 5 to the power k minus 1. Are you with me? Simplify 12 times 12 to the power k plus 10 into 5 to the power k minus 1. This is minus 12 to the power k. This is, open the bracket with the negative, minus 2 into 5 to the power k minus 1. Are you with me? Can you all simplify the like terms? Here I have 12 into 12 to the power k. Here I have just 12 to the power k. Can I simplify these two? How does it simplify? Here there are 12 times 12 k's. Here this is minus, just minus 12 k means this is minus 112k. Minus 1 times 12k. Can you see? So you can subtract 12. So this is like 12x minus 1x. Because they are the same term. 12x minus 1x is 11x. Are you with me? So this is 11 times 12 to the power k. And 5 to the power k minus 1. Here I have 10 of them. Here I have 2 of them. So then I get 8 5 to the power k minus 1. So are you with me? So now how can I generate a 7 here? How can I generate a 7 here? Okay, so what we'll do here is, our fk, I'm trying to generate a 7 out of this. Okay, so normally what we try to do here is we will try to break these terms, here. So fk is a 12 to the power k plus 2 times 5 to the power k minus 1, right? Okay, so look, this might require a little bit of practice to actually see this in at a first glance. So for example, you can see here we have 11, shall I say 12 to the power k is like an a term. So I have 11a plus 8b, right? Are you with me? 11a plus 8b. Okay. Now look at this. Okay, what is our fk? the fk we have is 12k plus 2 to the power 5k minus 1, which means I have 12 to the power k is what I used as a, right? Okay, so now shall I break this 11 up? I want to create a 7, right? I want to create a 7. So this 11 we'll break it up as what? 7a and 4a. Is that okay? 11a I'll break it up as 7a plus 4a, and then you have the plus 8b. Are you with me? I'm trying to break this up. So then following this format, shall we write it here? How does it work then? So the 11, 12 to the power k is the a here. So 7 times 12 to the power k plus 4 times 12 to the power k. It's the same thing. I just broke this up. I just split this. I'm splitting this. The other guy, we let it be there. 8 times 5 to the power k minus 1. Now, if you look at this very carefully, so I was keeping an eye on the fk. Okay, we have to keep an eye out for the fk to see this. So I get here 7 times 12 to the power k, and if you take a 4 out, can you see 4 is common, right? 4 into 12 to the power k and 8 into 5 power k minus 1. If I take a 4 out, what's remaining here? 12 to the power k plus 2 times 5 to the power k minus 1. Are you with me? And now if you look at this very carefully, who is this? 12 to the power k plus 2 into 5 to the power k minus 1 is our fk, right? 12 to the power k plus 2 to the power 5, 2 into 5 to the power k minus 1 is our fk. And we know fk is what? Divisible by 7, because it has been assumed. Right? So we can go with the fk. So you can see this is directly fk. So we on purpose created another fk inside here by splitting this. By splitting this, we are creating a fk. So this is one way of creating fk. Another person can use another different way to create fk. Like you could increase the 8 here. You can change this number. Now here I broke the 11 here. So another person could break the 8 also and actually create fk. That is also correct. That's another way to break it up. Okay. So I will do it in this manner. I'll show the other one also. So 7 into 12 to the power k plus this is 4 fk. So this is what? This is the equivalent of fk plus 1 minus fk, which means f of k plus 1 is 7 times 12 to the power k plus 5 times fk. Are you with me? So then what does this tell you? The k plus 4 plus 1, 5, right? Okay. Okay, this minus fk, I brought it over here and added with this fk, with the 4fk, and it became 5fk. Why am I taking this here? Because our task was to show that the k plus 1th term is divisible by 7, right? That's what we are supposed to do. Show that the k plus 1th term is divisible by 7. So now, if you take the k plus 1th term, there are two sections here. One is, one we can clearly see a 7. And the other one is made with fk. And what do we know about fk? Fk is definitely, we assume it's divisible by 7, which means if this is divisible by 7 and this is divisible by 7, the full expression is divisible by 7. Are you with me? And then give the conclusion. Before giving the conclusion, shall I show how to fix it with the other number? So if you fix it with the other number here, okay, let me show you how to fix it with the other number. So this was 11a plus 8b. I'm using a and b for convenience here, okay? A is 12 to the power k and b is 5 to the power k minus 1. We will not write that for the exam, but we will just use it to understand, okay? Okay, so if you try to split the other term, now I told you how to split the 12 to the power k and get it done. So if you are trying to split the 8 here and to get the same, to get an answer by splitting this guy, okay, what you do here is, okay, I just use for convenience 11a plus 8b. What is fk? Fk is 12 to the power k plus 2 to the power 5, 2 into 5 to the power k minus 1, which means in simple terms, it's a plus 2b, right? Fk is a plus 2b. Are you with me? Okay, so if I'm trying to split this 8b, instead of I don't want to touch the 11a now, I want to change the 8b. Only change this guy. So then do you see that to do that, whatever now here I have 11a. So then you can see that the amount you have, the coefficient of b is double the coefficient of a in fk, right? In the fk function, you have a plus 2b, you have double, right? This is 1a, here you have 2b. So here if I have 11a, I need to have how much b here? I need to have how much here? I need to have 22b. To make sure there is no difference to the sum, how much should I subtract to create the 8b? So 22, I have to subtract 14. 22 minus 14 is 8, right? Can you see that I am not doing any difference to the sum? Can you see that there is no difference to the sum? Okay, so this is my working. Let me take it out from here again. So fk plus 1 minus fk, let me do it properly. So this is how you write, right? 11 into 12 to the power k plus 8 into 5 to the power k minus 1. Now look, this was our rough working. Okay, they will not see these things. This is our rough working, what we think. This is the thought process, okay? So we will not show that. So I will break it now. 11 into 12 to the power k. The 8 into 5 to the power k minus 1, I am breaking it as 22 times 5 to the power k minus 1 and minus 14 times 5 to the power k minus 1. Can you see? Okay, so A and B. A is the 12 to the power k, B is the 5 to the power k minus 1. So now what's the advantage? Take 11 out and you get 12 to the power k plus 2 into 5 to the power k minus 1. This is the whole point. That's why, see, I can create the fk here now. Because I made sure that I had double this amount here. Because fk, when you looked at fk, you saw that b coefficient is double of a. So that's why when it's 11, I created 22 here. And to make sure that there's no change, we subtracted 14 so that we have the 8b still. Are you with me? Do you get what I'm trying to tell here? So this 8, using this model, I broke it up here. 8 is 22 minus 14. So then I took the 11 out and you can see 12 to the power k plus twice of 5 to the power k minus 1. Outside you have 14 times 5 to the power k minus 1. Who is 12 to the power k plus 2 into 5 to the power k minus 1? This is our fk. Are you with me? Okay, so this is an alternative approach. What I'm doing here is an alternative approach. Doing one of these two techniques should be more than enough. You will not do both of them. So then when you take fk plus 1 the subject, what do we get? 11 fk minus fk goes and becomes 12 fk minus 14 times 5 to the power k minus 1. And now what do we have to say about this fk? Fk plus the k plus 1th term. Fk we have assumed to be divisible by 7 and here you can see we have what? The other term has a 14. So 14 means it is definitely divisible by 7. So this entire term is divisible by 7. Are you with me? So then go with one of these two approaches. Now you can see these two values are looking different, but that is because we split it in two different ways. Okay, so in this way the answer you get like this, in the other way you get it in this manner. Go in one of these techniques, not both. Okay, one is more than enough. And then what? Give the final conclusion. So what's the conclusion? You will get a mark for that. If the result is true for n equals k, then it is true for n equals k plus 1, and then the next one, as the result has been shown to be true for n equals 1, then the result is true for all n. Okay, so this is the conclusion. Make sure you give the conclusion after you come to the fk plus 1 part. Okay, either here or here. Make sure the conclusion is there. Go in one of these two techniques. Okay. So I hope this paper has been clear with all of you. Okay, so this is the end of the this further pure paper.